Okay, so in chapter 2 we looked at solving quadratic equations. So one of the equations that we solved was this: 2x squared plus 9x minus 5 equals 0. And we factorised it to get x plus 5 upon 2x minus 1 is 0, which gave us two answers of minus 5 and a half. Now what we're really doing whenever we solve quadratics is we're finding where they cross the x-axis. So this quadratic crosses at minus 5 and a half, and it's a positive quadratic, so you know it's this general shape. Okay, so this is when we're solving quadratics, we're finding where it crosses the x-axis. Now when we go on to solving quadratic inequalities, we want to find the region where the given quadratic inequality is true. So our first one, x squared plus 7x plus 10 is less than or equal to 0. So we start off solving it as we would if it was an equation and it had an equal sign here. So our product is 10, our sum is 7, are two numbers that multiply together to give you 10 and add to give you 7 are 5 and 2. So it's x plus 5 upon x plus 2 is less than or equal to 0. So if we were just solving an equation, we would say our answers are minus 5 and minus 2. But what we actually want to see is where this graph is less than or equal to 0. So plot our points of minus 5 and minus 2 where it crosses the x-axis. It's a positive quadratic, so we know it's going to be this kind of shape. So it's going to be less than, the graph is less than or equal to 0 down here. So our answer is that it's less than or equal to 0 when x is between minus 5 and minus 2. So we'll write it as minus 5 is less than or equal to x, which is less than or equal to minus 2. Okay, our next one. X squared plus 7x is greater than 0. So we use basic factorising and we get x upon x plus 7 is greater than 0. So we know that this graph is going to cross the x-axis at 0 and minus 7. This is a positive quadratic, so it's going to look like this. And we want to know where the graph is greater than 0. So it's greater than 0 over here, and it's greater than 0 over here. So it's greater than 0 when x is less than minus 7, and it's greater than 0 when x is greater than 0. We can't combine these inequalities, so if you look at the first graph, this region was just one region, so we write it as a double inequality. These are two separate regions, so we'll write it as two separate inequalities. Okay, our third one, 2x squared plus 5x minus 3 is less than 0. So our product is minus 6, our sum is 5, two numbers that multiply together to give you minus 6 and add together to give you 5. 6 and minus 1. We rewrite our equation, factorise the two pairs, so you can see it's exactly the same as if you were solving a quadratic equation. The only difference comes whenever you get to this point here. So in a quadratic equation, we would just say our answer is minus 3.5. This, we're going to sketch it out. So it's minus 3.5 are the points that crosses the x-axis. It's positive, so it's this kind of shape. And we're looking for where it's less than 0, where the graph is less than 0. So it's down here. so it's between -3.5. So right, -3 is less than x, which is less than 1/2. Okay, so then you'll get questions as well that put it in some kind of context. So John's weekly pocket money, £p, satisfies the inequality p squared minus 8p minus 20 is less than 0. Work out the range of John's pocket money. So we take our inequality and we say our product is -20, our sum is -8. So two numbers that multiply together to give you -20 and add to give you -8 are -10 and 2. So we'll get p minus 10 upon p plus 2 is less than 0. So let's sketch that out. We know then that it goes through 10 and it goes through -2. So if we're just looking at this like a graph, we would say our graph is less than 0 down here, which would give us an answer of -2 is less than p, which is less than 10. But you have to think, does this work in the context of the question? Well, it's talking about pocket money. So you're not going to get -2 pocket money. Your parents aren't going to take £2 away from you every week, hopefully. So we have to change that to give us our final answer of 0 is less than p, which is less than 10. Okay, our next one then, number 5. The ages, years of people at an under 21 summer camp satisfy the inequality a squared minus 12a is greater than 0. Work out the range of the ages. So let's take our quadratic. This is basic factorising. So we'll get a upon a minus 12 is greater than 0. So we'll look at the graph. So that means it crosses at 0, so a is 0, or a is 12. We want where the graph is greater than 0. So if we were just looking at this as a normal graph question, we would say a is less than 0 and a is greater than 12. But we'll have to look at the context of the question. It's talking about the ages of people. Well, the age being less than 0 doesn't make any sense, so we ignore that. And it's an under 21 summer camp. So it says that here the age is greater than 12, but it has to also be less than 21 if it's an under 21 summer camp. So our answer then turns out to be it's between 12 and 21. So 12 is less than a, which is less than 21.